Welcome to Ask and Learn.
All right, so here we're given that f is big O of g, and that f and g are increasing and unbounded. And we want to prove that log of f is big O log of g. So just by definition of big O, we know that the absolute value of f is going to be less than or equal to some constant c times the absolute value of g whenever x is greater than some k, which we'll call k1. All right, so let's just take the log of each side. And so we'll get that the log of the absolute value of f is going to be less than or equal to the log of c times the absolute value of g when x is larger than k1. But we know that the log of two things multiplied by each other, right? So I'll just write this little rule in red. So the log of two things multiplied by each other is equal to the log of each one added together. And so we're going to use that because c is being multiplied by g, right? So we can parse that out and get that the log of f is less than or equal to the log of c plus the log of the absolute value of g. Well, of course, c is a constant. Right? And since c is constant and g is increasing and unbounded, then we know that there exists some k2 such that for all x greater than k2, the log of c is less than or equal to the log of the absolute value of g. And so this is for when x is greater than k2. Okay, so we're just going to let k be the maximum of our two k's here, k1 and k2. All right, so that gives us that the log of f of x is going to be less than or equal to, right? And so we're going to replace the log of c by the log of g of x, because we know that log of g of x is going to be greater than c, so we can say that. And then we're going to add in the log of g of x that was already there. Right, well, with this implies that the log of f of x is just less than or equal to 2 times the log of g. It's the absolute value of g. This is going to be when x is greater than k, right? Well, if we just let c1 equal 2, then we get the log of the absolute value of f of x is less than or equal to c1 times the log of g of x, absolute value, when x is greater than k, which is exactly what we wanted to show, right? By big O definition, this means that the log of f of x is big O, the log of g. Okay, and that will conclude the proof.